All right, so 16. We got a hemispherical tank and it's filled with water, has a diameter of 10 feet. Okay, so here's the deal. If you want to find total weight, there's a formula for that. It's total weight equals density times volume. And we are given the density here. We're told that the density is 62.4. And what you're not given is the volume. And we want the total weight, right? But you are given a way to find the volume. And how so? How so? Well, they give you the diameter of the hemispherical tank. Now, what is this hemispherical tank? Now, a hemispherical tank is half of a sphere. All right, so just picture this, right? A sphere is a basketball, and then just chop it off right through the middle, chop it off in half, and that's a hemisphere, right? A hemisphere is half of a sphere. So the volume of a sphere is 4/3 pi r cubed. But we want half of that volume, so we have to divide that by 2. You see what I'm saying? So when you divide that by 2, that's the same as multiplying by a half. So the volume of the hemisphere is actually equal to 4/6 pi r cubed, and then 4/6 reduces to 2/3, so it's 2/3 pi r cubed. That's the volume of the hemisphere. So then we got everything we need. We got the formula for the volume of the hemisphere, right? All we need is a radius, and they tell you the diameter is 10, so that means the radius is 5. So we got the radius to get the volume, and we got the density. So we're ready to go. So let's go ahead and find that volume. So then it's going to be 2/3 pi 5 cubed. All right, let's plug that into our handy dandy calculator. 261.799. So that's the volume of the hemisphere. Okay, so we got volume now, and we got density. So if we want the total weight, well, then that total weight is going to be equal to the density, which was 62.4, and then times that volume we got, which was 261.799. So then let's just take that number we just got and multiply it by the density, 62.4, and that's 16,336. That's the answer. Okay, so number 17, which measurements are justified by this similarity? So we're told that the triangles are similar. And to answer this question, what we'll do is we'll examine the options and pick the one that's correct. So in the first option, it says that AD is 3 and AB is 6 and AE is 4 and AC is 12. Now let's examine this. Here AD is 3 and AB is 6, which we could say, all right, here the scale factor is 2. 3 times 2 is 6. But then that doesn't make sense because we have a different scale factor here. 4 times 3 gives you 12. So which one is it? Is it a scale factor of 2 or is it a scale factor of 3? That makes no sense, right? The scale factor has to be the same for both sides. So then the answer cannot be choice 1. Let's look at choice 2. It says AD is 5, and it says AB is 8, and then it says AE is 7, and then it says AC is 10. Well, what's the scale factor here? It's not going to be a whole number, so let's work it out. It's 8 divided by 5, whatever that number is, 1.6. And then here it's 10 divided by 7. 10 divided by 7 is not going to be 1.6. So the answer is not 2. Okay, so what I'm doing is I'm just testing each of the choices, and I want to make sure that I get the same scale factor on both sides, because that's what's supposed to happen with similar triangles. All right, so AD is 3, AB is 9 for option 3, and then here it says AE is 5, AE is 5, and then AC is 10. This is not going to work either. So by process of elimination, the answer is choice 4. So you want to look at it anyways? Why it's 4? Sure, let's take a look. So AD is 2, and then AB is 6, and then here AE is 5, and then AC is 15. That works because 2 times 3 gets you 6, and then 5 times 3 gets you 15 here. Same scale factor. All right, 18. So I have a formula for these types of questions to get the area of the sector. And it's not always as simple as plugging into a formula. Sometimes you have to work a little harder, as you'll see here. It says FH is congruent to OG. All right, and now if FH is congruent to OG, well, check this out. OG is also congruent to OF because this is a radius and that's a radius. And OF is also congruent to OH for the same reason. These are radii, right? OH is a radius, OG is a radius, OF is a radius. So all these line segments, except for GH, all of these line segments are congruent to each other. So then that would mean that this triangle here is equilateral, means all the angles here are 60. And then this one here would be 120. And then this would be 30, and then this would be 30. All right, so then what do they want? They want the area of the sector FOH. So they want area of sector FOH. They want the area of this sector. I'm going to just go ahead and color it because I like the color. All right, so they want the area of that sector. Well, here's the formula. It's going to be the central angle over 360. The central angle is 60 degrees. So when it says central angle, it means this angle right here. So 60 over 360, and then times the area of the circle. Well, what's the area of the circle? Well, the radius is 6, so it's pi r squared. So that's going to be pi 6 squared. So the area of the circle is 36 pi. So that's the area of the circle. So it's 60 over 360 times 36 pi. 60 over 360 is 1/6, so it's 1/6 times 36 pi. Well, multiplying by a sixth is the same as dividing by 6. So 36 pi divided by 6 is 6 pi. So the answer is 6 pi. Okay, so number 19, the topic tested here is similar triangles and their properties. And we're given that triangles AEC and BED are similar. And what we are supposed to do is, given that they are similar, which of these proportions is true? So that implies that 3 of them are not true. So what I'm going to do is I'm going to go ahead and separate the triangles. Okay, so I separated them. And according to this, I got triangle AEC, AEC, and triangle AEC corresponds to triangle BED. So a couple of things to know about this. Sometimes it helps to just write AEC and put it right on top of BED. Just put them right on top of each other. Sometimes it helps to do that, right? Put them on top of each other. So from this statement, see, I didn't even have to separate the triangles. I just do that just to do it. But if you just look at the statement, the similarity statement, that tells you that angle A corresponds to angle B, angle E corresponds to angle E, and angle C corresponds to angle D. It also tells you side EC corresponds to side ED, right? You see how I'm just looking at side EC and then it corresponds to ED. And so on and so forth. You can actually say many things just from looking at that similarity statement. And from the similarity statement, you can also even write proportions. So, for example, side AE over side BE. So you can say AE over BE is equal to what? We can say EC over ED. You see that? So you can even write proportion statements just from the similarity statement. And then that's what they did here, right? So they wrote a bunch of proportions, and then your job is to just look at each of the options and pick the one that's true. So let's go ahead and look at the first one. So the first one says side CE. So it's looking at side CE. And then, by the way, the order also matters here. The order of the lettering is very important. So they got side CE. So side CE over DE. So that's so far so good. CE over DE. So far that's good. Is equal to EB. And then you see what they did there? They switched the order around. So they started like with the top over the bottom, and then now they're going bottom over the top. And then that means this is not going to be good. That's just not going to work, right? Because if you're going to go ahead and finish this CE over ED, one way you could finish it is you could say EA over EB. And then you see here it's switched around. So that doesn't work for us. That won't work. So let's keep looking. Let's look at the second option. See what the second option says. The second option says AE over BE. So AE over BE is equal to AC, okay, AC over BD. Yes, that works. That's the answer. All right, so number 20. The topic here, again, similar triangles and their properties. But I think I can also add dilation just to be more precise. So it says a triangle is dilated by a scale factor of 3 with the center of dilation at the origin. Which statement is true? So we spoke about this in brief earlier. A couple of things you need to remember. When we dilate, the following occurs. So the angles remain the same. So then that means that option 4 is out of the question. Okay, so the angles remain the same. Option 4 is out because it's saying that the measure of each angle in the image is 3 times the measure of the corresponding angle of the original triangle. That's not going to be true. Just because you dilate it by a scale factor of 3, that doesn't mean the angles are going to be 3 times as big. It only means that the sides are going to be three times as big, right? The lengths will be 3 times as big, and the perimeter will change by the scale factor, but not the measurement of the angles. So now what did I just say, right? So I just said the lengths and the perimeter change by the scale factor. So let's see if that pops up in any of the choices. So choice 2 says the perimeter of the image is 9 times the perimeter of the original triangle. That is wrong, right? The perimeter is supposed to be 3 times. That's what I'm telling you here, right? The lengths and the perimeter change by the scale factor. So then choice 2 is now out of the question. And then the third thing I say here is the area changes by the square of the scale factor. Well, what was the scale factor? The scale factor was 3. What's the scale factor squared? It's 9. So the area should be 9 times. And that's what option 1 says. So the answer is option 1. And then this is something that I do cover in one of my videos. I have a similarity series. It goes similarity 1, 2, 3, 4, and I think it goes up to 5. I'm not sure if it goes up to 5. But in one of those videos, I talk in detail about the ratio of the sides, the ratio of the perimeter, the ratio of the area. So check out those videos if you're curious about that. And then the slopes, I don't know, they're just putting that in there to confuse you.